All right, good morning, class. We are on the last section of notes today, so be aware of that. You've got a test coming up on Monday. Tomorrow we're going to do a Zoom review session, and we'll have one on Saturday as well. So if you need help on your corrections or on any homework, then just reach out to me, email, call, or text. All right? So today we're going to be finishing up our volume of pyramids, cones, and spheres. So let's get started with the volume of a pyramid. Okay? To find the volume of a pyramid, you're going to take a third times your base area times the height of the prism. So notice here that I have two different types of pyramids. I have one that's a triangular pyramid, and it's called a triangular pyramid because notice that the base along the bottom here is in the shape of a triangle. Okay? And so you would have to find the area of that base, then multiply it by the height of the prism in order to, or the height of the pyramid. Notice that the other one here, that this is a rectangular pyramid, okay, and that it has a rectangular base on the bottom. So the formula here is going to be slightly different, right? The formula is length times width for a rectangular pyramid to find the area of the base, and then to find the area of the base of a triangular pyramid, that's base times height divided by 2. Okay, so let's do an example of this. Let's find the volume. Okay, let me go ahead and give this, we'll do this one here. So if I have 8 centimeters, plug in some values. This here is 6 centimeters. Okay, I'll go ahead and make this a right angle along the bottom here. And I want you to notice very carefully that I'm going to put in a height here, but this height is going to extend from the center all the way to the top of my pyramid. Okay, and this will be 5 centimeters. Okay, so we want to find the volume now of this triangular pyramid. First, we have to start with the base. Okay, so to find the base height, I need the base of the base triangle times the height divided by 2. Remember, you're looking for the right angles with triangles to find your base and your height. So here's the right angle down at the bottom right. And extending from that right angle is 6 centimeters and 8 centimeters. So that's what we'll plug in here. 6 times 8 divided by 2. 6 times 8 is 48, divided by 2 is 24. So the base of my triangular pyramid now is 24 centimeters squared. Okay, so we're going to plug that in for the base of our triangular pyramid. Now, what is h? Notice here that this h is different. This is the height of the pyramid, not the height of the base triangle. So that's going to be this distance here from the very center of the pyramid all the way to the top. That's how tall the pyramid is. So notice that this height here is going to be 5 centimeters. Okay, which is different than the height of the base, which is laying flat at 8 centimeters. Okay, so let's plug this in. The volume is equal to 1/3 times the base that we just learned to be 24 times the height of the pyramid, which is 5. Now you can evaluate. 1/3 of 24 is 8 times 5 is equal to 40. And our units are here are centimeters cubed. So the key with this when you're evaluating volume of pyramids is going to be careful about what numbers relate to the base and what numbers relate to the height of the entire pyramid. Okay, let's move on to the volume of a cone. It's going to be similar to a pyramid in that you're going to first need to figure out what the base is. Notice on a cone that the base is a circle. Okay, so the volume of a cone is going to be 1/3 times pi r squared, which is the area of a circle, and then times your height h. In this picture here, remember that this would be your radius, is the distance from the center of their circle to any point on the outer edge. And then the distance from the center all the way to the bottom peak here, that's going to be the height. And you can plug those values in. So let's do an example here. Let's go ahead and say that the radius here is equal to 5 millimeters and that the height is equal to 7 millimeters. Then I can plug those values in here to my volume formula. The volume is equal to 1/3 times pi times the radius, which is 5. Make sure that you have the actual radius and not the diameter. Sometimes they'll give you the diameter, in which case you have to divide by 2 in order to find the radius. and then multiply that by your height of 7. Okay, so now I have the volume is equal to 1/3 times pi. 5 squared is 25 times 7. So now let's multiply 25 times 7. So the volume here is 1/3 times pi. 25 times 7 is 175. Remember, when you're multiplying by a third with a fraction, how do you multiply fractions? Straight across. So this is really the volume, 1 times 175, 175 divided by 3 pi's. So you could type that into your calculator like this, 175 divided by 3, and then multiply it by pi, which we could use 3.14. Then you should come up with a final answer here of the volume to be 183.2 millimeters cubed. Okay. Now have a sphere here drawn for you. Okay, this here is a sphere. Kind of looks like a globe. And so the volume of a sphere is equal to 4/3 times pi r cubed. Notice here that this radius, r still stands for the radius, but here we're going to cube it when we're talking about a sphere. Okay, so let's do an example of that. Let's come over here and say that let's say that for this one that the diameter is equal to 16 inches, okay? And so notice here that they gave us the diameter and not the radius. So to remedy that, we're going to have to take that diameter and divide it by 2 in order to find the radius. So 16 divided by 2 here is going to be 8. So the radius is 8 inches. That's how far it is from the very center of our sphere all the way to any point on the outer edge. Okay, so I could plug that in over here to my volume formula. Volume is 4/3 times pi times r, which is 8 to the third power. Notice that this is not 8 times 3. This is 8 times 8 times 8. So 8 times 8 is 64, times 8 again is 512. So the volume here is going to be 4/3 times pi times 512. Okay. Remember now we can multiply our fractions. You can switch the order because of the commutative property. So you can have 4/3 times 512 as a fraction. You could put it over 1 times pi. So to evaluate this, you could multiply 4 times 512, which is 2,048. Then divide it by 3 pi's. So divide by 3. And then you can multiply by pi. So to plug this in your calculator, I would put in 2,048 divided by 3 times 3.14 here, and then hit your enter button. Okay, for a total volume now of 2,143 and 6/10 inches cubed. Okay, and that's how you find the volume of a sphere. We have one last word problem here. A spherical scoop of ice cream has a diameter of 6.3 centimeters, is placed in a bowl. Find the volume of the ice cream. Then find how long it would take the ice cream to melt if it melts at a rate of 2.1 centimeters per minute. So this problem has 2 steps. So for step 1, we need to find the volume. The volume is going to be equal to 4/3 times pi r to the third power. Okay. Notice here in this problem that it gave us the diameter. Okay, but we want the radius. So to find the radius, we would have to take the diameter and divide it by 2. So if I have 6 3/10 as my diameter, when I divide it by 2, this is going to be 3.15, which I can now take that radius and plug in here to my volume formula. 4/3 times pi times 3.15 to the third power. Okay, remember if you're raising it to the third power, you can either multiply it 3 times, 3.15 times 3.15 times 3.15, or you have a caret button on your calculator. Remember, it looks like that. So you can go ahead actually and type all of this into your calculator at one time in order to be the most accurate. Okay, so I would use parentheses here, 4 divided by 3, and parentheses, and times pi if you want to use the pi button or the number 3.14, and then times 3.15 caret 3. Then press enter. Okay, so you want to be very careful that you're telling the calculator to do your operations in the correct order, because your calculator will follow the order of operations. Okay, So now you should come up with the volume here is equal to 130.9 centimeters cubed. So we've answered the question of what is the volume of our ice cream. However, the second part of this problem asks us now to how long will it take to melt? So step 2, let's think about this. If it melts at a rate of 2.1 centimeters cubed per minute, remember a rate should indicate to you to set up and solve a proportion. Do you remember those? I think you should. We just spent a long time on them. So remember, a proportion is you have one rate equal to another rate. So here, if I say that ice cream melts at 2.1 centimeters cubed, so that's my units that are on top, 2.1 centimeters cubed per 1 minute. Then I want to know that if I have my volume is 130.9 centimeters cubed, how many minutes will that take to melt, right? So I've now set up my proportion, and to solve a proportion, remember you have to cross multiply. So you can multiply now 2.1 times x, which is 2.1x, and set that equal to 1 times 130 and 9/10. Okay, and 1 times 139/10, see 2.1x is going to be equal to 130 and 9/10, right? Divide both sides by 2.1. So that way when you solve for x, right, you should come up with 62.3 minutes. So approximately, if there's 60 minutes in an hour, take approximately an hour for your ice cream to melt, okay? So maybe it's not here in Florida, because something tells me if you're in Florida, your ice cream will melt a lot faster. All right, so that concludes today's lesson. If you have any questions, please reach out, email, call, or text. I'm available to you guys from 8 a.m. to 8 p.m. and throughout the weekend, okay? I want you guys focusing on these corrections. I want to get these grades up. Some of you are doing excellent. You're doing very, very well. And some others, we need to take the time this weekend to make sure that we understand this material before our test, okay? So your test will be on Monday. Have a good weekend. Bye.